Okay, now, let's discuss the responses to an increase in body temperature when the body is hot. The rise in temperature is detected by thermoreceptors in both the skin and the hypothalamus. The skin responds by producing sweat, which is secreted by the sweat glands. As the sweat evaporates from the skin surface, it removes heat from the body, helping to cool it down. At the same time, vasodilation occurs as the arterioles widen, increasing blood flow to the skin. This allows more heat to be lost through radiation. Hair erector muscles relax, causing the hairs to lie flat and reducing the layer of trapped air, which further increases heat loss. Combined, these mechanisms effectively lower body temperature, bringing it back toward the normal 37 degrees Celsius. In short, sweating, vasodilation, and hair flattening work together to promote heat loss through evaporation and radiation. Next, let's look at the responses to a decrease in body temperature when the body is cold. The drop in temperature is detected by thermoreceptors in both the skin and the hypothalamus. The body responds through several mechanisms to conserve and generate heat. Vasoconstriction occurs as the arterioles narrow, reducing blood flow to the skin and minimizing heat loss by radiation. At the same time, hair erector muscles contract, causing the hairs to stand upright and trap a layer of air close to the skin. This trapped air acts as an insulating layer, reducing heat loss. Shivering also occurs, involving rapid involuntary contractions of skeletal muscles. The energy released during respiration in these muscle contractions generates additional heat, warming the body. Together, these responses raise body temperature back toward the normal 37 degrees Celsius. Hair standing upright, vasoconstriction, and shivering all work to conserve and produce heat, demonstrating how the body maintains thermal balance. Heat always moves from warmer to cooler regions, and in this context, the body reduces heat loss through radiation, while conduction and convection also play a role. The maintenance of a constant internal body temperature in mammals relies on several coordinated mechanisms. One of the key processes is sweating. When the body temperature rises above normal, sweat glands release sweat onto the surface of the skin. As this sweat evaporates, it absorbs heat from the skin, effectively removing excess heat from the body. This cooling effect helps bring the body temperature back toward the normal range. Conversely, when the body temperature drops, shivering comes into play. Skeletal muscles contract rapidly and involuntarily, generating movement without producing significant physical work. The energy required for these muscle contractions comes from respiration, and part of this energy is released as heat. This heat production raises the body temperature, helping to restore it to the optimal level. Together, sweating and shivering act as complementary processes to maintain thermal balance in mammals. In addition to sweating and shivering, mammals use other mechanisms to maintain a constant internal body temperature. In cold conditions, the hair erector muscles contract, causing the hairs on the skin to stand upright. This traps a layer of air close to the skin, which acts as an insulating barrier, reducing heat loss by radiation and conserving body heat. Blood vessels in the skin also play a key role through vasodilation and vasoconstriction. When the body is hot, arterioles widen in a process called vasodilation, increasing blood flow to the skin's capillaries and allowing more heat to escape to the environment, thereby cooling the body. Conversely, when the body is cold, arterioles narrow through vasoconstriction, reducing blood flow to the skin, which limits heat loss and helps maintain the internal temperature within the normal range. These mechanisms work together to ensure that the body remains close to its optimal temperature of 37 degrees Celsius. When discussing heat transfer from the body, it's important to note that heat always flows from warmer areas to cooler areas. The body loses or gains heat through three main processes. Radiation involves the transfer of heat as electromagnetic waves from the body to the surrounding environment. Conduction occurs when heat moves through direct contact between the body and another object. Convection involves the transfer of heat through the movement of fluids, such as air or water, which carry heat away from or towards the body. To summarize, the table compares how blood vessels respond to changes in body temperature to help maintain a stable internal environment. When the body is hot, vasodilation occurs, meaning the blood vessels widen. This increases blood flow to the skin, allowing more heat to be lost through radiation. The skin may appear red as a result, and the overall purpose is to release excess body heat. Conversely, when the body is cold, vasoconstriction takes place, causing the blood vessels to narrow. This reduces blood flow to the skin, trapping heat within the body and conserving core temperature. The skin may look pale, and the primary purpose of this response is to prevent heat loss and maintain a stable internal temperature. Finally, here is a summary of how the body maintains a stable internal temperature through homeostatic control. Thermoreceptors in the skin and hypothalamus first detect any change in body temperature. This information is sent to the hypothalamus, which acts as the control center and coordinates an appropriate response. Effectors in the skin, such as sweat glands, blood vessels, and muscles, then carry out actions to counteract the change. These responses work to reverse the temperature deviation, bringing the body back to its normal level of 37 degrees Celsius. Once the temperature is restored, the corrective responses stop, maintaining balance and preventing overcorrection. That wraps up Unit 14.5, where we explored the key aspects of temperature control. I hope you found it helpful. Stay tuned for the upcoming lectures, and don't forget to check out the notes linked below.